Okay, I had an experiment a year ago. I had the same question for those people. So I created an application that crashed. I wanted to measure how much time a developer spent with a tricky crash. So I took this application to a meetup. There were about 50 people there and asked them to fix it. And it was amazing to see how they spent 20 minutes silently to find the solution. I realized that they actually enjoy it. So I can say that I'm sure that you love bug fixing. I know this because you're here. You are at a certain level of coding, and you don't get there unless you love to find solutions for problems. So it's strange. What can I think about it? I think you didn't lie. But it's not the bug fixing that you don't like. What you don't like is the time pressure, the stress that comes with it. Bugs always come in bad time. And this stress makes you feel clueless. So what I want to do in the next few slides is to talk about why you feel clueless, and I hope it will help you to be less stressful the next time. We will follow a very simple crash. We will follow how do we find the reason of that crash, and then we will learn something. I will use a 50-year-old model for this. This was created for formal derivation of applications 50 years ago. It's one of its basic elements is the weakest precondition that tells you about a program where you need to start it from if you want to end it in a specific state. You do this day by day automatically, but not formally. I see you why. This is how it looks like on paper. And we will not use this version. I just do a graphical notation instead. So you have a very simple instruction, a very simple program, S, and you want it to end successfully. So you want your boss make happy, run it. And there are some states when it will do well. Otherwise, it just ends up otherwise the expected state. What is the program and what are these states? The program is a series of state transitions. Like in this case, they just move a Q point from A to B. S1 moves it right 10 pixels, S2 moves it up 5 pixels. And if you compose them into one program, then it just moves it from P to R. And if you want it to to get there, you need to run it from here. If you do something else, it will go wrong. It can go wrong a few different ways. Like if you mess up S1, that it will end somewhere where S2 couldn't move it to the right position. Or maybe S1 can take it out of the screen, and then it crashes. So enough of the theory. I think the model is pretty simple. Let's look some code. I created an extremely simple application. It gets a list of tasks, executes them sequentially, and keeps that small timestamp updated on the bottom of the screen, telling where it will finish. If you follow the states, which we will not do, we see that it does a task, updates the time, and does the next task, and then after the last task is done. If I run it, I got this stack trace. Let's see what went wrong, and now I will slow down time. We will analyze what you do every day. So we see it died in that line. That's actually not my method, it's something else. It's something I used. It died in the 22nd line with a division by 0. So we know that elapsed was 0. Elapsed is counted in the previous line from the parameter start and the current time. Now we know that if we code this method with a start that is equal to the current time, it will die with this exception. And we don't need the details anymore, that's it. Now comes the hard step. We need to leave this code and remember this. We see that we use this method here and use the start that we initialized there from current time is. Now we know that this part went too fast, and we actually assume that task will not finish in a millisecond. Good. So we know the weakest precondition of this method. It will crash with the arithmetic exception if the first task is too fast, otherwise it will run well. We create the quick workaround. Actually, that became blue, good, finishes well, now it's always good. Why is it hard? I think you not usually fix an easier code than this. But let's count how many pieces did we need to remember at the same time. We had to understood this one. That's one. The second, third, and then we went out to our method. We had to understood this, 4, 5, 6. This is 6 pieces. Something you should know about your brain, your short-term memory has about 7 slots for these kinds of information. After it, you start forgetting pieces, and I think you remember as you tried to debug and forgot the method you just read a few minutes ago. Do you know this? Okay, cool. That's good. It's not just me who's stupid. So one important thing to remember, have a pen and a paper. Anytime you exit a method, just write it down. Okay, just to sum up the first half, you shouldn't panic. You all love debugging. Who loves debugging? No. Okay. You love it. It's a hidden secret that you want to explore. And you want to make something perfect. That's what you are doing. And have a pen and a paper with you. But still, it's a bit complex task to find an error. I think if we found the reason, then it's easy to fix usually. So at Samebug, we wanted to help you out with finding similar cases using only stack traces. So you get a crash, we take your stack trace, and want to find people or information on the internet that is similar to yours. So this time, we needed to understand what makes two stack traces similar. Sorry. Let me drink a little. So what makes two stack traces similar? Simple text similarity didn't work. So we took the ending of the stack trace and said, we call it a prefix, even if it's an ending, but it comes at the top. So we call it a prefix, and as you remember, if you see this, you know that you derived from this information that the start was equal to current time release. And you can make a note. And I think the stack trace prefix is the fingerprint of this situation, of this weakest precondition. If you have this note from someone else, it can save you the time of tracing back the state transitions one by one and going out to the next method, which makes it extremely hard. If you take a longer one, then we know that our method was called with a task that executed too fast. What makes this useful and that one not useful? Actually, this may be a library method that someone else uses. So you can use his solution. This is something that only you know. Maybe you can tell the support if they see this stack trace, they can just answer that the first task was slow. So we collected 1.5 million stack traces from the internet. From Stack Overflow, GitHub, Google Groups, crazy forums, and collected all the common prefixes that appeared in many stack traces. And if I go back to my original stack trace that I showed in the beginning, you can see that if I take just one frame, I see 12,000 different, I see it on 12,000 pages. The next one appears only less than 10,000, then it decreases well. And if I go down enough, I have only one. So we thought if we would have the notes from those people who got those stack traces, it would help you, it would save you to follow these transitions. And we actually have it because they are the pages we have found these stack traces on. So we created a simple visualization that shows how you get to the more and more specific case. You can see the numbers are the same, but it helps you to feel visually how it, yeah. So this gray one that you can't see is actually my search. And the one I found was created by someone on GitHub who actually asked about it from the support. And it actually very closely matched to my situation. So we like this. Of course, we don't have as many solutions as Google have. But in crazy situations, when the message and the exception type is not enough, it's very powerful. And then we had these 1.5 million stack traces. And wanted to see some structure in them. It's really hard to cope with this many information. And we used the same visualization. The thing we did is that we looked into what happens here. So now it was just another case, but that may be also important or interesting. So this is what we call prefix maps. This is ClassNotFoundException. That's very generic. If you go down one frame, this is actually Java's basic default class loader. And if it's very generic, not unless like the Minecraft modders class loader. And if I try to find my case here, it's somewhere here. So I drill down there, focus on that one. This is something I don't know what actually does, but I see something familiar here. You will know this. You remember your first JDBC tutorial? When you mistype the driver name, you get this. Actually, there are other cases there, but I'm sure you all met this. And this is my original stack trace. This is the common part that was the same as the guy who asked it on GitHub. And it's pretty long and very specific. Actually, there are close to 200 neighbors on that line. So now I would go into the tree and show you another case. We can talk about it as a family tree. And this is the case I had about 2 years ago. I got an open exception wrapped into something. The message was timestamp. Timeout, sorry. And this was the code. I don't know if you would like to debug it. I don't. I didn't have this map that time, but now I do. So I looked it up this week. There is some error, but don't care about that. So basically, this was my case. There was no timeout. It should have been a ClassNotFoundException, actually. I just wrote a bad name of a driver, and it's actually Slick, which is Scala's database layer. And so I got this crazy thing. And a very close relative to it on this tree is something completely different. The only common thing is that also comes from Slick. And the solution in this case is fix the configuration. In that case is Slick upgrade. So then we analyzed the libraries by numbers. We associate the prefixes to the library of the entry frame. And wanted to see what are the top libraries. And this is just the numbers of non-root prefixes from libraries. You can see that our library recognition is not perfect, or many people searches for their own application stack traces. I think it's not surprising. Pardon? Yeah. And Tomcat was pretty popular a few years ago. I don't know how is it now, but I think it's about 10 years history. So another list could be the number of web pages containing these prefixes, and it's pretty similar. But something that was more interesting is the average number of prefixes, average number of pages those prefixes appear on. And you can see that JDBC drivers make you confused. Okay, now something completely different. Previously, we analyzed the stack traces to find someone who can help us to fix our bug. But then we wanted to see if we collect a large amount of crashes, can we find the ones that belong to the same bug? Which means if we fix one of them, all the rest will go away. So we took our own stack traces collected by a crash reporter, a popular crash reporter service, and created a map of them. And wanted to see which bugs are the most important to fix. So this is how our map looks like. You can see that the most important one is this one. It actually causes 33% of our crashes. And I will talk about a few of them. So let's look into that. This is actually a dead MongoDB. It's dead because the queue is full. It cannot accept any more jobs. And the interesting thing was that the crash reporter reported it as 137 different bugs. I didn't want it. But why did it do? Because many of our functions try to use that dead MongoDB. And of course, they generated very different stack traces, so it was unable to group them. At this point, I know if the guys fix the queue problem, we're done. But I wanted to do something else. So I dig down on that road. And if I go down that pretty close, I will show you live later. So pretty fast I get to a point where I see that we try to read stack traces. So if we cache them, it's done. On the other side, we read solutions. These are actually the web pages we collected for the prefixes. And if I fix both of them, we got rid of 33% of the crashes. This one's one good, but the next one isn't that good. So this is a case where we try to use a Netty client that is closed already. We use it to download solutions from the internet. So if I dig into it, I don't see my own crashes. I mean, don't see our own stack traces. Why? Because Netty is asynchron, and we forgot to handle its errors. It always started a new thread, and that thread contained only their frames, so we didn't have any information to fix it. But it was easy to say, okay, just look at the places where we use Netty and just handle those exceptions and wrap them into our ones. So it's not done, it's somewhat in a pending situation. So let me show you another case which tells you why it's impossible to group automatically. This is our OAuth authentication, and we are unable to recover the state after a successful login. And it comes at the same time from Facebook, Google, and GitHub. What does this tree tell us? It tells that there is a generic error related to our OAuth login. So we need to fix it there. If I would get only the Facebook version, then I would need to fix that. So this is the end of the prepared talk. So I just want to wrap up. You shouldn't panic. You'll love it. Keep a pen and a paper with you, always. Try to look for similar cases. Ask your colleagues. And fix just the most important bug first. So now, since I see that I have a few minutes left, I would like to show you it in live. It went out about 3 hours ago. So it can be buggy and it can be slow, but let me try it. I think I need to. Okay, I think now you see it. So it's there. If you want to analyze your stack trace, you can click this button. I don't do it live. I just show you my one. So this is the stack trace I showed you. You can look at the details, and you can see the different patterns. This is the less specific one. And then you can see the pages it appeared on. If you see the most specific one, then you can see someone else searched it too. And this is the GitHub page I found the solution on. And this is the map that is not visible just for special users yet. The other thing is that, okay, you can explore our crash library. I will show you Java runtime error. What you see here is the most popular patterns, the packages that contain the most patterns, classes, method, and so on. If you look at the pattern, we call prefixes patterns. So sorry for mixing this up. You can see the map. You can see the actual prefix traces. And if you have any editor access, you can actually annotate them. And yes, you can also see the typical messages. That helps a lot of times. And then you can drill down to other cases. You also see the typical messages here. You see the stack trace, and then you have a larger map. I don't know why it stayed here. So you can, and of course you can drill down and see the more and more specific cases. So that's the public library that we found on the internet. If I look into our workspace, you can see this MongoDB case here. And if I drill down on the widest road, yeah, these are the cases I told you. This is when we try to read a stack trace. This is when we try to read a solution. And I can say that why is Mongo. And that's it. And then if I reload the map, it appears there. It's not fully real time. And you can see the Netty case here. This is something MariaDB SQL error. Of course, this can't be fixed by the root, and I don't know what the rest are. Okay, that's it. And something special just for you. So if you want to get access to the search engine with the map, and you want to get editor access to the tree, so you would like to annotate it, just register. I hope it works. If it doesn't, just drop us an email on info and refer to Devoxx Ukraine in the subject. And we give you the access. Okay, so now if you have any questions, please ask. Yes, would you give him a mic?
Hello, and thank you for your speech. It was quite exciting. And yeah, it's actual for most of developers to get understanding what is happening and how we got to this situation, especially in production. But I wonder, for now, this site, Samebug.io, it is like a service, right?
Pardon?
It is a service. So
Yes.
to get our traces analyzed, we have to upload this somehow, somewhere. Is there any chance to get it as library and include into maybe production release cycle or things like this?
Yes. Yes, it is.
Wow.
So the easiest way is to contact me or my colleague. Please stand up. Right after the presentation, and let's get contacted and we discuss the details.
Okay, thank you so much.
If it is possible, and please anyone else who want to get this analysis, please contact us. Yes?
Thank you for your speech. It was amazing, but I wasn't here from the beginning. But I have some questions. What's the aim of your project? Are you going to provide some commercial support, or it's just for community?
Okay, so first, it was a few years ago. We wanted to actually show it on the beginning of the presentation to help out bug fixing. So when you are in difficult situation, when Google doesn't help, because it just uses the exception type and the message, and that's not very specific as you've seen on the map, then we thought we can give a better solution. And many times we do, but it was really hard to monetize it. So then we turned towards something like those guys mentioned, analyze the crashes of companies, to find bottlenecks, find structural errors, and to connect people within the company to help each other when they have the same bug.
Okay.
Did it answer your question?
Yes, maybe I understand. As a private user, I can use it like for free, yes? And if I'm
Yes.
a company, I can ask you for some broad service, yep?
We have, okay, so we're planning to roll out our Sentry integration in a few weeks. So if you have a Sentry, you can just connect it into it and we will give you this map. If you don't have Sentry, then you need to contact us and we find a way to give an integration for you.
Okay, thank you. Thank you.
And please, and it actually helps us. Users help us because we have this technology. We have a few ways to use it, but I think the best ideas can come from you. I think it could be used for support, it could be used for automate few things like in the MongoDB case, in the night, it would restart MongoDB and drop you a mail that in the morning, please check out what got wrong. So it can be used for many things, but now it's just a technology that we just roll out, and we need you to help us to actually keep it live, because of course, we need to make it helpful. Okay, no more questions. And thank you very much.